Hi, my name is John Harity. I'm a business development specialist with Schneider Electric Supply.
I'm happy to present to you today a solution from Schneider Electric for the Lexium 32i. Schneider Electric is the only major industrial automation manufacturer that has a fully integrated servo motor that was AC only. So it's AC in, AC out. A lot of the others out there will have DC bus, so it's DC in and AC out for the AC motor. What you're looking at here is a very streamlined design. This takes less than 3 minutes to assemble. You have your power stage, you have your communication card. There's also a configurator online that you can use to assemble all the parts into the correct bill of material. I have this demo set up here with an HMI PLC combo communicating over CAN motion to the amplifier. Now you may notice the wiring here looks very, very simple, and that is on purpose. The design is simplified to reduce cabling and also to save space in your cabinet. By using an integrated servo motor, you can cut installation costs and the time it takes to implement a solution by 30 to 60%. It's been proven. This motor comes in two different flange sizes, 70 millimeter or 100 millimeter, and you also have one-phase and three-phase motors available. The one phase is 110 230 volt AC and goes up to 1.3 kilowatts. And the three phase is 208 400 volt AC and goes up to 2.2 kilowatts. Now, what's jammed into this really compact package is a lot of functionality. You have 4 inputs, 2 of which can be assigned for mark registration inputs. These capture inputs support 2 microsecond jitter time for accuracy, and you have 2 outputs available to you. And another feature here for the encoders is you have 15-bit resolution for standard encoder, which is 32,768 counts per revolution. For the high resolution encoders, you have single turn or multi-turn. These are true absolute encoders available in 17-bit resolution, and that gives you 131,072 counts per revolution. Really great for packaging applications, material handling applications, material working, and also printing applications.
In packaging applications, for example, when you have a bag making machine, the back of the bag you'll have a flap that shows a registration mark. This registration mark is detected by a sensor which tracks the exact position of the encoder on the motor at that time, and then after a certain number of additional encoder counts pass, the motor comes to a precise stop before filling the bag and then sealing the top. Another example of a packaging type application would be a pharmaceutical bed of pills, for example. And especially if there's printing on the back. This very precise printing with cutting and perforating is almost always done with a servo motor. In the material working industry, you can really think of cutting machines, etching machines, punching machines, any of these machines that would modify or enhance a particular material, such as aluminum or steel. You can think of paper, any paper that you buy at the store. It's precisely cut. Index cards is another great example. All these are very precisely cut. There's a machine that does this through cut to length. Another example is the lead that you'd use to refill a mechanical pencil. All of this lead is cut to a very precise length, and you can see here it's very, very level. Without further ado, let's go ahead and take a look at the demo I have configured here. If I turn the power stage off, I can move the shaft of the motor. Otherwise, it's locked down, trying to retain its position at all times. And here you can see as I move the shaft clockwise, this object on the screen rotates across the conveyor. And likewise, if I go back counterclockwise, it rotates left. So if I turn the power stage on here and implement the start-stop, it's going to move the ball to the right and then back to the left. As it's moving right, the green light turns on the stack light. As it moves left, it's been programmed to turn the red light on the stack light. Very simple movement. This is absolute positioning being demonstrated here. It returns to 0 every time and goes forward to 45,690 counts on the encoder. Now you can program this in inches or user units depending on the application, but I left it as the default.
In fact, the amount of time it takes to program this is less than 10 minutes to get the motor moving. That is demonstrated in a separate video here. Please take a look and see how easy it really is under the hood with the Sew Machine software. This is a combination HMI PLC product and implements the PLC Open version 2.0, which is a very nice library and updated version of the PLC Open libraries that bring a lot of advantages and benefits for applications. That concludes the demonstration here. I might as well show you the fastest speed. This is running at 60 RPMs right now. If I go ahead and increment it to speed number 4, you can see it's running at 2,600 RPM. For more information, you may contact any one of your Schneider Electric supply account managers, and we'd be happy to come on out and give you a demonstration. Thanks a lot for watching, and have a great day.